Good morning, students. So in our last class, from the exercise 6.5, from the question number 3 up to question number 4 we have done, has not it? So today we have to start from question number 5, and I hope all of you understood the first 4 questions. Now the question number 5, which one is an algebraic question here, and if you see this question, the question is given like in this way: find the local maxima and local minima if any of the following functions. Find also the local maxima and local minima values as the case may be. And if you see the question number 5 here, fx equals to x cube minus 6x square plus 9x plus 15. So this one is the question here. So this question we have to solve here. So let's start here now. How can we solve this one? Let's see. So as you see here, first of all, the question number 5 here given that first of all we write down the function fx equals to x cube minus 6x square plus 9x plus 15. Now first step we have to differentiate this result. If we differentiate this one, then f dash of x equals to 3x square ddx of x cube 3x square ddx of 6x square minus 12x ddx of 9x means 9 and ddx of constant term 0. No need to write. So f dash of x equal to we get here 3x square minus 12x plus 9. And after that the next step is here we have to write f dash of x equals to 0. F dash of x equals to 0 we have to write to find out the critical point, and now in place of this f dash of x we have to write this result. So that's why here we write 3x square minus 12x plus 9 equals to 0. And now here 3 is common, so that's why here remain x square minus 4x plus 3. And if we factorize this one with the help of middle term splitting method, we get the result here x minus 3 into x minus 1 equals to 0. All of you know how to split this one. So from here we write either x minus 3 equals to 0 or x minus 1 equals to 0. Isn't that it? So now from here the critical points are we get x equal to 3 and x equal to 1. So after that what you have to do? We have to verify these 2 points at x equal to 3 and at x equal to 1, in which point we get maximum value and in which point we get minimum value. For this we have to apply the second derivative test to verify this result. For that reason here what you have to do, when we have to apply the second derivative, so first of all we have to differentiate the result again. If we differentiate the result here again, we write f dash of x, and if we differentiate the result, then here we get ddx of 3x square means 6x and ddx of 12x means only 12 and 9 is there, so ddx of 9 constant term 0. So f double dash of x equal to we get here 6x minus 12. Now one by one we have to verify the result. So when we have to verify, first of all the first critical point is here x equal to 3. So when we put x equal to 3 in second derivative, that means in this place we have to put, in place of x we have to put 3. So when we put 3, then if we calculate the result 6 into 3 minus 12, ultimately 6, that means a positive value we get. So remember this one is not the value, this one is just a verification. So here we get positive means greater than 0. Greater than 0 means what we get? We know in case of second derivative greater than 0 means we get a minimum value. So that's why here in bracket written minimum. So here our conclusion we have to write, therefore fx has minimum value at x equal to 3. So this one is the verification. Now we have to find out the minimum value. And the minimum value, when we have to write this x equal to 3, we have to put on the given function. And the given function is x cube minus 6x square plus 9x plus 15. So in place of this x, if we write 3, then 3 cube minus 6 into 3 square plus 9 into 3 plus 15 we write. And then if we calculate this result, then we get the answer is 15. Is it clear? So this one is the minimum value. Similarly, another critical point is here. The critical point is x equal to 1. Is not it? So if you see the critical point is here x equal to 1, this one. So this critical point we have to put here again. So here when x equal to 1 we write, if you put this critical point on the second derivative, then 6 into 1 minus 12. Ultimately we get here minus 6. Minus 6 means what? A negative value. So negative value means less than 0, that means we get here a maximum value. For that reason here we write therefore fx has maximum value at x equal to 1, our conclusion. And now here in this case, when we calculate the maximum value, this one again we have to put on the given function, and the given function is x cube minus 6x square plus 9x plus 15. And when we put this x equal to 1, then we get the answer is 19. So from here we can say our conclusion is what? The maximum value is 19 and the minimum value is 15. Is it clear? I hope all of you understood this one. So now here in this way, some more questions are here in question number 3. This one is the 5th one. And again, if you see the next one, next question is here gx equal to x by 2 plus of 2 by x, isn't it? X by 2 plus of 2 by x. So now let's see how can we solve this one. So in this case, first of all, what you have to write? The next question is here, question number 6, this one. So in this case, we write given that gx equal to x by 2 plus 2 by x. So in this case, if you differentiate this one, so here 1 by 2 is constant term, ddx of x is 1, so that's why simply here we get 1 by 2. Is it clear? Similarly, the second one is here 2 by x. So 2 is the constant term. If we keep this one take outside, then ddx of 1 by x we have to differentiate. So ddx of 1 by x, we know ddx of 1 by x means here written you see minus 1 by x square. So if you differentiate this one, then we get here minus 2 by x square. Understood this one? And now after that we have to write zdex equal to 0. Zdex equal to 0 we write in place of zdex, again we put this value 1 by 2 minus 2 by x square. If we shift this minus 2 by x square on the right hand side, then 1 by 2 equal to 2 by x square. And if you cross multiplying this one, x square equal to 4. And if we take the square root, x equal to we get here plus minus 2. And here the critical points are we get plus 2 and minus 2. Is it clear? Now one condition is here, and the condition is what? Already given as also written here, since x is greater than 0 given to us, isn't it? X greater than 0 given to us, so that's why here the negative value is not possible. So we take only the positive one, and the positive value is x equal to 2. Is it clear? Now we have to verify this result. For this, what you have to write? We have to differentiate the function again. G dash of x is 1 by 2 minus 2 by x square. So if you differentiate this one again, ddx of 1 by 2 constant term 0, and second part is minus 2 by x square. So minus 2 is the constant term. If we keep this one outside, then we have to differentiate ddx of 1 by x square. So ddx of 1 by x square value is minus 2 by x cube. You see, so already minus is here in z dash of x, so that's why here minus minus plus and 2 to the 4, that means ultimately we get here 4 by x cube. So when we differentiate second time, the answer we get 4 by x cube. All of you understood this one? And now we have to put this point. So when x equal to 2, if we put in the second derivative, so 4 by 2 cube, that means 1 by 2. 1 by 2 is a positive value. Positive value means what? Greater than 0. If greater than 0, that means we get minimum value. So that's why here written, so gx has minimum value at x equal to 2. And when we have to find out the minimum value, so minimum value is z of 2, and the function is here x by 2 plus 2 by x. For that reason, in place of x, if we put 2, then 2 by 2 plus 2 by 2 here. Ultimately, the answer is what? 2. Is it clear? So this one is the minimum value here. I hope all of you understood this one. Isn't it? So in this way, now one more question is here. Question number now 7. 3, 7. 7 is here, gx equal to 1 by x square plus of 2. This one is very interesting question here. Gx equals to 1 by x square plus of 2. Now let's see how can we solve this one. So the third question is here, gx equal to 1 by x square plus 2. Now we have to differentiate this one. So how can we differentiate this? First of all, the denominator part, this one we assume as an x. So it is of the form 1 by x. So ddx of 1 by x is, we know, minus 1 by x square. So that's why if we assume this x square plus 2 as an x, so that's why here we write minus 1 by x square. X square means x square plus 2 whole square. All of you understood this one? So this x square plus 2 we assume as an x. So that means it is of the form 1 by x. So we write minus 1 by x square. So that's why we write here 1 by x square plus 2 whole square. But we assume this part, but it is not x. So that's why again we have to differentiate this part, the assuming part. So ddx of x square plus 2. And if we differentiate this one, ddx of x square means twice x, and ddx of 2 constant term 0. Ultimately z dash of x equal to, we get here minus twice x divided by x square plus 2 whole square. Is it clear? Okay. Now here, after that we have to write g dash of x equals to 0. So g dash of x means minus twice x divided by x square plus 2 whole square. So in place of g dash of x, we have to write this result. And from here, if we find out the critical point, and the critical point we get here, x equals to 0. Isn't it? So now in this case, after getting the critical point here, g dash of x equal to 0, when we write, then x equal to, we get the critical point. Now g dash of x is minus 2x divided by x square plus 2 whole square. So here one more thing here. If we apply the second derivative, you see here the numerator, here in numerator x is there, as well as in denominator is also x is there. So if we put 0 here after differentiation, so it is of the form 0 by 0. So when we get 0, so the second derivative test is not applicable, so we have to differentiate one more time. So in this way we have to differentiate. So this one is a long process here. So for that reason here, we have to apply another one. So that means the first derivative method we have to apply. All of you understood why we apply here the first derivative? Because in case of second derivative, if we get greater than or less than, then we can say maximum or minimum. If equal to 0, then we can't say anything. So we have to differentiate one more time. Only for that reason here we have to apply another method. So that's why here the local maxima and local minima method we have to apply here. For that reason, first of all, what you have to do, the critical point x equal to 0 is here. So for local maxima and local minima, we have to consider the right hand side as well as we have to consider the left hand side. For that reason, just we assume 2 points. On the right hand side, we assume a positive value, which one is 0.5. And when for the left hand side, we assume another point, which one is minus 0.5. Is it clear? For just we assume these 2 points. Now these 2 points we have to put on the g dash of x. On g dash of x we have to put this value. So when we put the negative value, here you see in place of x, if we put minus 0.5, minus minus plus positive, so that means as a whole the whole result is what? Positive. Positive means what? Greater than 0. So only for that reason here you see g dash of x is greater than 0 we write. Is it clear? Similarly, again, if you see in place of x, if we put 0.5, then already minus sign is there. That means the whole result is negative. Negative means what? Less than 0. So that's why here we write g dash of x is less than 0. Understood this too? So just we assume these 2 points by our own, and just we check out in which side it is positive or in which side it is negative. So positive, that means greater than 0, that means the graph is increasing, and when less than 0 or negative, that means the graph is decreasing. Only for this reason here, just we draw a diagram, and here x equal to 0, 0.5 minus 0.5. So here in the left hand side, In the left hand side the graph is what? Increase, so that's why here graph is increase. You see this part is increase, and the right hand side part is what? Decrease, so that's why the graph is decrease. So when we draw a graph, always we draw the graph from the left hand side. So from the left hand side the graph is increase, and now from this x equal to 0, from here the graph is decrease. So first increase then decrease. This one is the condition of maxima. All of you know this one. In local maxima and local minima we solve this. So that's why here first increase then decrease, that means it is the condition of maxima, isn't it? Only for that reason here we write therefore gx has maximum value at x equal to 0, and the maximum value we have to put this one on the given function. Given function is 1 by x square plus 2, so in place of x if we put 0, then ultimately the answer we get here 1 by 2. Is it clear? I hope all of you understood these three questions. One more question remain here in question number 3, question number 8, fx equal to x root over 1 minus x. So this question we have to solve in our next class. If you understood these three questions, you have to copy these three questions properly, and if any questions are there, then you can ask me directly. Is it clear? Okay, thank you.